I'm Urja Acharya from University of Nebraska-Lincoln, presenting our paper on inference of user qualities in shared control. Shared control augments user control with autonomy so that users and robots can work together to achieve a common goal. Robot autonomy is important because users may not always provide optimal input, and user inputs are vital to keep users engaged in the system. In shared control, different people have been found to desire different level of control. People with high internal locus of control desired more control at the expense of optimal performance, whereas people belonging to high external locus of control were relatively more comfortable to give up control to autonomy. This difference highlights the need to develop shared control that adapts to users' intrinsic qualities for improving holistic user-robot performance. We investigated how people with different locus of control performed with different types of shared control by developing two different modes of shared control using artificial potential fields. Restrictive mode, which was implemented with linear drop-off, provided less control to the user but was optimal, and relaxed mode, which was implemented with exponential drop-off, which provided more control to the users. We then assessed the performance in both systems through user study with the telepresence robot. Participants were first asked to complete 2 laps in the training obstacle course, after which they were moved to the main obstacle course where their performances metrics were tracked. Based on locus of control, users were classified into high internal, high external, and average group, and their behaviors were analyzed. High internal group were found to have highest number of commands and highest percentage of command conflict in both control modes, suggesting their desire to control. They also performed their task faster and traveled smaller distance in relaxed mode, but their performance was not optimal due to their larger deviation from optimal path. Average group were found to have larger number of commands and larger number of command conflicts in restrictive mode than in relaxed mode. For high external group, it was found that they had larger deviation from optimal path and covered larger distance in relaxed mode, but they also had fewest commands in relaxed mode, which suggests that they were more patient with autonomy. From the graph, we can see that performance matrix of high external groups stood out among all the users as they had largest path deviation, largest percentage of command conflict, largest distance in restrictive mode, and they also had largest duration in relaxed mode. Our results support our hypothesis that locus of control can be inferred through user interaction and assessment of robot performance. On inferring the user qualities, robot autonomy can also be switched between modes for optimal performance. This provides guidelines to implement and operationalize user adaptive shared control strategies in order to improve holistic user robot performance and also to increase user adoption.